Welcome to Risk Roundup. The birth of the World Wide Web and the invention of the Internet was only a few decades ago. The magnitude of that invention and the advancements that have since occurred in computing and communications are not only connecting humans across nations, but fundamentally changing their lives as we speak. Since each new idea, innovation, and technology brings us transformative potential, there is a growing belief that the ongoing technology transformation in the cyberspace would play a central role in increasing equality and fairness and bring us power to transform the world in not only cyberspace but also geospace and space, in short referred to as CGS. While cyberspace can bring us a force of equality, the dawn of artificial intelligence, in short referred to as AI, is also giving us a promise of a level playing field across CGS where everyone, irrespective of race, religion, class, or connections, would have an equal opportunity in not only education but employment, entrepreneurship, survival, success, satisfaction, and a shot at prosperity. However, as machine intelligence is becoming more ubiquitous and systems are being controlled in not only cyberspace but also geospace and space, the emergence of evidence and data of biased algorithms is leading to growing concerns of algorithms making judgment calls. So, how are machine learning algorithms becoming biased? What are the implications for nations, its government, industries, organizations, and academia, in short referred to as NGIOA? To discuss biased algorithms, I'm delighted to welcome Lars Wood to Risk Roundup. Lars Wood is the CEO of Quaiswarm and also heads Lars Research, a Montana company deploying patent-pending quantum artificial intelligence, in short referred to as QAI, cognitive reactor, collective intelligence for cryptocurrency, blockchain, solo and pool mining. In addition, Lars is also visiting scientist at MIT, CIA, FBI, NSA, White House, and more. He's based in United States. Welcome, Lars. We are honored to have you on Risk Roundup.
Thank you very much. I'm happy to be here.
Wonderful, Lars. So, the digital global age gave us a hope that the ongoing technology transformation would bring the much needed equality, transparency, fairness, and a level playing field. While the potential for technology transformation across CGS remains and is huge, is the ongoing technology transformation bringing us a tool for equality and fairness?
Well, with respect to machine learning, specifically supervised learning, which is the majority of what's taking place. Many years ago, when I was a chief scientist at GT Government Systems, which is now parts of General Dynamics and Verizon, we had the first large-scale Department of Defense contract for machine learning using algorithms that I invented that were supervised learning. They were patented by GTE, and the implementation was interesting because we found it to be impossible to not have bias in the results. And you can think of it this way, that the supervised learning algorithms are, for all intents and purposes, what's called a match filter. A match filter is a digital signal processing technique. The difference between that does the same thing as a supervised learning algorithm does, like backpropagation and others. The difference is that you have to program the match filter. It takes a lot of sophistication to do that. With the neural network, you train it, but it has its own set of difficulties. The main issue is that the neural network, the supervised learning neural networks, really want to not be general. In other words, what you like to have is broad generalization, so you pick up a lot of cases that you haven't trained into the system. But the algorithms don't want to do that. They want to be very narrow, and so in order to force them, which is what you have to do, force the algorithms to have good generalization, you have to overfit the training sets in different directions. This is completely independent of dirty data or a human doing it or what have you. It's just how these supervised algorithms work. If you don't do that, they will not work. They will have poor generalization. The result of this is that it's like having a bug that you can never get rid of. Okay, and our project was very successful, but we had to bias, in order for it to work, we had to bias the system, the supervised learning algorithms. We had to bias the training sets to be selective toward the problem that the government wanted us to detect, which is a very complex problem in satellite communications. However, in discussions, there were two big things came out of this, as I said. One was a question, this is back in 1989. One was a question, what's the difference between existing technology and the neural networks? And the other one was, can you ever get away from this overfitting thing? And as I said earlier, the only difference, the neural networks, the supervised learning algorithms, are effectively match filters that you don't program. They're the same thing. They do the same thing. And match filters have been around forever. So have neural networks, for that matter. However, because of these issues, they went into disfavor. Many years ago, Marvin Minsky wrote a book called Perceptrons, which discredited supervised learning for almost a decade. And I spoke to him about this, and he was concerned about the claims that Rosenblatt, who first came out with the perceptron, which is the kind of supervised learning, was making, and basically really smashed him pretty good. However, even myself, in the case of my own work back then, Rich Sutton, who was a colleague of mine, he's one of the he and Andy Bartow invented reinforcement learning. Rich is at the University of Calgary, and Andy's at UMass Amherst in Massachusetts. And Rich was concerned because during this period of time, the GTE was a center for machine learning and artificial intelligence. All of a sudden, there was a whole lot of people there, researchers that were of high regard with respect to machine learning and artificial intelligence. And I ran all the artificial intelligence laboratories at GTE Government Systems. Rich was concerned that the supervised learning algorithms would not converge. And from a theoretical perspective, he's correct, because things like backpropagation cannot, there's no convergence proof. And so what you have to do is you have to basically train them to a good enough. So if you train them to be very close to full convergence, that generally is not good because you'll have very narrow generalization. So generalization is being able to recognize a man from a woman, for example, okay, as humans. If you get below like 70% convergence, the generalization is spotty, okay? So we'll recognize some things but not others. So between 75 and 85%, we found was a good area. So you didn't have to get full convergence. In fact, it wasn't even desirable. All this stuff that's taking place today, the algorithms are no different than they were back then. In fact, Jeffrey Hinton, who I had spoken to about this back in the late 80s when he was working with Rumelhart, who I knew personally. Rumelhart was actually the primary inventor of backpropagation and working with Hinton. He died of Pick's disease and actually visited me at my laboratory at GTE and gave a talk at the labs. This issue has always been there, but the backpropagation, these supervised learning algorithms are the easiest to implement, and the algorithms have not changed. What's changed is the computer processing power has increased dramatically. It's very fast, but more importantly, very cheap. Also, as a result of that, software infrastructure, so you don't have to be really sophisticated to use these systems. There's all kinds of toolkits and so forth available now to facilitate building these things. The problem is with the ease of use is that people don't understand that there are these risks associated with these technologies. And as it has been shown with Apple, they have grossly underestimated with the iPhone X its ability to do facial recognition. They've had, some pretty embarrassing, in Japan, I believe, some people created a wax or a rubber mask and was able to fool their facial recognition. They've been able to have these types of algorithms think a picture of children in a field is a gun. Okay, if you understand how the algorithms are biased, okay, or the training sets, how they have to train, then you can fool the algorithm. So this is actually a vulnerability. So it's like something you can hack into as well. So you can literally hack into neural networks that are supervised learning because you can exploit their bias. So it's not a kind of issue where you're gonna like somebody comes out with a gun and robs a bank type of issue. Okay, it's an insidious issue where you won't necessarily know it's taking place. It's just embedded. So, for example, online testing, scoring, loan applications, all these kinds of things. And in fact, the head of research, the head of the machine learning research at Google, joked during an interview, or rather a talk he gave, because Elon Musk has been talking about the killer robots and all this kind of nonsense, okay, which is not quite, that's impossible with the current machine learning. It's not even close, because these machine learning algorithms, it's like construction technology. You'll be able to make some really tall buildings, but you'll never reach the moon. You can't. So he said, this is to say, the head of research, Google machine learning research, watch out for machine learning bias. That's the problem. And everybody recognizes it that understands the technology. The problem is it's starting to go everywhere, and you're gonna have people. I mean, I even would question if I know machine learning is involved with, and then I know it's going to be supervised learning because, with the exception of QAI, there is no reinforcement learning technology that doesn't take hordes and hordes of data. Google tried this and with AlphaGo, and they were successful to an extent, but the problem was it took a ton of data. But that's because of, the way they implemented it. The approach we've taken is completely different. It's a fine-grained learning, so you can think of these little tiny neurons that don't learn very much, learning very quickly, all in parallel. So it's very different than the existing machine learning, rather reinforcement learning algorithms. However, the big issue is that as a result of that, Andy Ng, who was formerly of, I forget the name, well, he was the Google of China, has sort of set the direction for the Chinese to basically use supervised learning, and everybody's going in this direction. And it's just going to cause these very subtle, problems. They cannot be engineered around. It has nothing to do with dirty data. You cannot fix it. You cannot use another neural network to try to get rid of it because that one has the same problems. Okay, so it's a fundamental flaw in all supervised learning algorithms that cannot be removed. So that's an issue.
Yes, now I hear you on that, and you gave a really good comprehensive understanding about what the problem is and why we are here, where we are addressing or where we are talking about this very critical issue. And as you said, that humans, they introduce this bias in that for the system to work. Like you said, the government wanted certain functionality, or they wanted to address certain issues. So there was a need to embed that bias into the machine learning neural network algorithm that you were developing. And same is the problem, just like, all the software developers, they are focused on functionality and they don't focus on the security. And similarly here also, to make the algorithm do what the designer wants it to do, the software designer, we are not thinking about how it's going to impact, what the broader impact is going to be as the algorithm gets bigger and bigger, and as it gets embedded into much larger systems, not only at local level, but national level or global level. So as artificial intelligence tries to be dependable digital data decoder, we are seeing all these numerous AI-based tools, technologies, and processes that are trickling into everything from driving directions to dream jobs, loan applications to college applications, and so much more. Governments are using it, industries are using it, organizations are using it, and even NGOs and academia, everybody is using it now. So amidst this growing visible signs that the digital global age has decided to depend on the AI-based digital data information infrastructure, do we have any dependable algorithm at this point?
No. Be clear. I want to be clear on this, and I actually said this on LinkedIn in response to somebody that was saying, well, it's the people that are creating the training sets. It doesn't make it's fundamental to the algorithms. It has nothing to do with the person that's designing the training set. So even if God were to create the training set to be perfect, it would still be skewed. You can't help it. If you had a machine that was doing it, it would still be biased. So these supervised learning algorithms are fundamentally and inherently biased. You cannot get away from it. It doesn't make a difference how you try. Okay, so given that these supervised learning algorithms are so easy to deploy, in contrast to unsupervised or reinforcement or recurrent networks and a whole bunch of others, the supervised learning algorithms are ridiculously easy to use. For example, if you were designing a match filter, you'd have to have the sophistication of at least a master's level degree in digital filter design to be able to do a match filter. Okay, with a supervised learning neural network, you don't need anything. It's trivial to use the toolkits. It's almost like what they used to call script kiddies, the hackers that really don't know how to write the viruses. They basically get the tools and they just apply the tools. It's the same kind of idea. The point being is that you can't get it out. And because everybody is using these supervised learning algorithms, it's going to be everywhere. And the only way that you can deal with it at this point in time is to be aware of it. In other words, question the results of the output of these systems. If you don't feel that something makes sense, question it, because it could be biased. And it may not be biased on 70 out of 100, but the other 30 it could be, and it could bias. Like for example, another example was the facial recognition that I believe, again, Apple was using was thinking that or resolving. They don't really think; it really is pattern recognition systems. That black people were apes. Okay, it was identifying them as gorillas and things like that. So these are all as a result of this. And so the way they fixed it is that management calls and say, "Hey, we got a problem," and the engineer goes back and essentially play, the whack-a-mole game where it's a child, in an arcade where you hit the little hammer and you knock these things down, and they keep popping up in different directions, and the idea is how fast can you knock them down, and that's how you get score. It's like that kind of game. So what the engineer does is, push in another direction, and that opens up another bias. You follow what I'm saying? So that it's like having a technology which is fundamentally flawed, that you're using to do important things. Now, if you understand what the narrow nature of this and with the bias that's involved, you can have reasonable success. So, for example, the technology we deployed for the government, which resulted in a $350 million contract many years ago, that worked the way it was supposed to. But we knew that where the holes were, and we're able to when the results came back that were not the way we wanted them to be, we understood what the issue was. Today, because of the way that they're using these things, they just apply them like some kind of black box, and you can't do that, okay? Because if you do, you're going to run into trouble. Might not be right away because these neural networks are ridiculously hard to debug. Okay, that's one of the problems that we encountered. All machine learning systems are like this. You think about bugs in software. Machine learning bugs are the worst because the software tries to correct effectively for the bug. So it takes you much longer to find logic bugs in machine learning systems than it does in other systems. That, in other words, let's think this breaks because it tries to adapt based upon the bug in the software. So it's really a big problem that is going to affect everybody around the world. Decision support systems are being implemented with this stuff, and it's all supervised learning. All supervised learning.
Yes, I hear you. And I mean, we expect machines to be compassionate outside of their rigid point of view and free of these human biases and be objective. But as you are saying that the technology is fundamentally flawed and there is no way out of it. So what can be done? I mean, is it possible for intelligent machines to be objective? Will we be able to fix this problem that is growing so rapidly? And are intelligent machines that we are trying to create based on this supervised learning and neural networks, are they defined and designed to be inherently objective, or are they purposely designed, as we talked before, to have some short-term goals that we are defining, we are introducing bias, and sometimes we are not even introducing bias, that the data that we are using, it is biased, and that there are so many other variables and so many other entry points where the bias just enters. So what can be done? What are the options for us?
There's only, if you're going to use supervised learning, there's only one option, and that is to have human intervention. And that's what we did, back in the late 80s when we saw these kinds of things. You have to have human intervention. You cannot just believe the outputs blindly. You must have human intervention. So if there are questionable results, you have to have the human in the loop to basically override what the system is recognizing. That's the only way. So because humans, don't make these kinds of insidious mistakes unless there's something wrong with them, of course. But if you don't have a human being involved to basically make sure that the supervised learning algorithms don't result in incorrect pattern recognition, because that's all they are. Okay, I don't care if they're deep networks or three-dimensional networks, or I don't care what they are. They're all anything based upon supervised learning, whether it's a training set where there's an error that's propagated back through the network, where weights are adjusted, where there's simple processing units, you're going to have this problem. And the only way to deal with it is to have humans involved. The problem is that because of the cheap availability of this stuff, I mean, anybody can do this. You're not going to have this kind. You can have these apps that arise that have this bias, and there won't be any human being involved because the people treat them as black boxes. That's the huge problem. I had one of my mentors was Eric Ellingson, who was the chief engineer at the MITRE Corporation, which is the think tank for the Air Force. And he always would say, you cannot apply any of these, even the digital signal processing, like a Kalman filter. We had problems. We were trying to project the trajectory of intercontinental ballistic missiles for intercept. This is back in, the Space Defense Initiative. And, people would say, well, we use a Kalman filter, which is good at that. And he would say, no, that's not how to do it. You need to first work it out by hand to understand what's going on before you just throw a black box at it. Once you apply the black box, then you can understand where the black box has shortcomings. And that's what they have to do here. But the problem is, they'll be so widespread, it just won't happen, except in the huge corporations. The government should have regulations that there's human intervention for the supervised learning systems that they're implementing. And we're not even talking about nefarious applications of, supervised learning, where they're trying to recognize, classes of people or something like that, or educational background. Who knows? We're talking about just normal use. So you have to have human intervention. It's the only way to deal with the problem. You can't engineer it away. It's impossible.
No, I hear you on that, but you make a very interesting point that we have to have humans involved at each stage. So, what is the role of the humans when we are talking about these machine learning techniques that are so complex and obscure in their workings? I mean, it seems like we may not be able to get clarity on bias by simply assessing the data or the details of the data or the algorithm, what kind of algorithm we are using. So, what is the potential of bias that creeps into the AI, and how can humans, with their involvement, how can they control that bias in getting into the algorithms, and what can human do differently that these neural networks are doing?
The only thing that can be done is a human override, so that you can basically say, I don't like the results of this test, and then there's, by regulation, and that's the only way this can be done, because otherwise people won't do it. You need to have a law that basically says for some of these important things like healthcare or what have you, that there's a human override. That you can basically say, I don't like this diagnosis. I don't, that this thing came out with, and so I want to have a human intervention take place. That's the only way. So with the healthcare, it's the most dangerous, in my opinion, because these pattern recognition systems are, have a high, can diagnose in incorrect ways due to the bias. So you need to have the ability to make push a button and say, I don't agree with this. Just like you can have a second opinion with a doctor, you have a right to a second opinion in both healthcare providers relative to insurance and so forth. You have to have the ability to say, I don't agree with this. So, because otherwise what you're going to get is that, well, the machine learning can't be wrong because the people that use the stuff have no clue. The machine learning can't be wrong, so that's just what it is. It must be true. You have to have the ability by law to be able to say, I want human intervention here. I don't agree with the results. Period. End of story.
But Lars, we can have the legal aspects and regulations. They are a whole different story. We can discuss that. But how do we first find bias in this mind of machines that is being developed? Is there any test for that?
The only way, it's only by exception that you're going to find it. So in other words, when something goes wrong, it's sort of it's like a proof by breaking it. So you're only going to find it by that it does the wrong thing. Some of these folks that have been attacking the vulnerabilities of these machine learning, these supervised learning systems, because that's really the only one that has the problem. Supervised learning, anything that has a training set is biased. So and that's why I don't use them. And that's why when I saw this way back in the late 80s, early 90s, they said, I'm not going to have anything to do with this. I'm going in a different direction. And it took me a long time to work through the issues, but we've been successful. But in terms of supervised learning, there's no way to engineer around it. The only way that you're going to find out that there's an issue is that somebody's going to complain. And if they don't complain, it's just going to go on like nothing went wrong.
Sure, but there needs to be an understanding to be able to complain, and not the common people, individuals and entities that are using this. They don't have understanding. Corporations, maybe their technical department, they have some understanding about what is happening, what kind of bias has gotten into the machine learning system that they have developed for screening the applicants to call them for interviews or any other purpose that they have. But the common people, they don't have an understanding that anyone applying for an interview for a job, they don't know how the applications are going to be screened. So when they don't get called, they just expect that, oh, they didn't make a cut. But they don't understand that they didn't make a cut because of maybe, there is a bias that has gotten into the system. So the problem of this bias in machine learning is likely to become more significant as the technology spreads across NGIOA and as more people without a deep technical understanding, as they are tasked with deploying it. So the problem is that we don't know how widespread the machine learning based decision making technology is at this point. Is it even possible to know how widely adopted AI, these neural networks and supervised learning is currently, and whether there is any testing going on, whether there is any organization that is involved in testing all these algorithms. Because for softwares, we have version 1, version 2, version 3, so we know which version has bugs and whether we can effectively remove that. But with these machine learning technologies, algorithms, there are no different versions, so
No,
we are stuck with what we have.
that's right. So you can. It is possible to have versioning on the training sets and on the on the supervised learning, but you generally don't hear about it because all they do is it's modified in the back end of the system, and then it just results in a new neural network that basically they deploy immediately after testing. So you can version anything, of course. So, but the point being is that the only way that I've been able to, I mean, it's the way we dealt with the problem. Is a manual override, where you basically can say, this doesn't look right, and I'm going to question the results, and you have to have that ability in the same sense that you can file a complaint for discrimination. This is nothing more than a different form of discrimination, if you think about it. So the discrimination laws could be easily applied to these machine learning systems by just saying, I disagree with this, I believe I've been discriminated against, and that's what it really is, because it's biased you out of some class or put you into one. You're probably not going to complain if you're biased into something that's good, but you're going to be unhappy if you're biased out of something. So if you treat it as a discrimination, then existing laws could be applied to deal with it. But you have to have the ability to have a manual override where you can basically say, I disagree with this. And the basis for that is probably, currently existing discrimination laws that basically are meant to deal with human discrimination. But here, because the humans are being replaced by these supervised machine learning systems to do a lot of the work that they used to do for filtering and so forth. Just like on the telephone, how many times have you worked with the Verizon or your pick your provider, and the thing is, happily saying, it sounds like you're unhappy. Do you want to talk to a human being? And I just keep saying agent, 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 because I worked at GT, I knew what they were doing, and I knew the flaws of these systems way before they were deployed. GT Laboratories had an extensive speech recognition research program going on that led to the kind of stuff you see today, where you don't talk to operators anymore unless you say agent several times. There's a human override there. You say agent, or operator or whatever a number of times, that system's going to kick out and basically bring a human being in. And that's exactly what has to take place. I mean, that speech recognition is a kind of machine learning, okay? It may not be based upon neural networks, but nonetheless, it's a kind of pattern recognition that comes from artificial intelligence research. Same thing with vision processing systems. They're commonplace today. It used to be considered artificial intelligence because of the heuristics that were involved. The neural networks in the old days of artificial intelligence were a tiny little piece of artificial intelligence that many people didn't like because of Marvin Minsky's critique of those systems. He shut down PhD theses for over a decade in this stuff, okay? Because he basically said this stuff is garbage, doesn't work well. And so if you're a PhD candidate and you're going to say, I'm going to present this is what I want to do for a thesis, and you're going to go and basically say, I want to do something that the top guy in the field says is garbage? No, okay? And so no PhD students were using neural networks for any of this kind of stuff for over a decade. And as I said, I talked to Marvin Minsky about this, and he said he was just so pissed off, that's what he said to me, that Rosenblatt had made these outrageous claims about what these things can do, that he basically, maybe he went overboard, because it certainly did, put a damper on the whole research area for a long time. In fact, when I got into it, that's why, people were saying, oh, that's bad stuff. All my AI colleagues were saying this to me. Be careful of that. And you have to understand, you just really have to, if you're going to use the stuff, and I wouldn't, Okay, I wouldn't go near supervised learning with a 10-foot pole. Okay, uh, but in terms of it being out there because it's easy to deploy, or any variant of it is easy to deploy. Even Jeffrey Hinton, who's been pushing this stuff with Google, he was interviewed. I saw a month or so ago, and thought that maybe back propagation isn't so great. He knew it wasn't great a long time ago. Okay, Jeffrey Hinton's a smart guy, and I've spoken to him. Back before he was with Google and famous and everything else, when he was doing the Bolsa machine back in the 80s. And he understood the issues with this stuff. Okay, he worked closely with Rumelhart, and I knew Rumelhart really well. So the point being is that you really have to have a human override and apply existing laws to basically say, I feel like I've been discriminated against, because there are no, I don't, there's no machine learning bias laws, but there are discrimination laws.
Sure.
And the difference if it's a human being or a stupid supervised learning, pattern recognition system. If you feel like you've been discriminated against, file discrimination, complaint in whatever venue you happen to be.
No, I hear you on that, and that's an excellent point that you made about human override by continuing to say, agent, and then we would be connected to a human, after a few minutes, hopefully. But like you said, there is a need for this kind of accountability, and there is a need to promote equality, transparency in this algorithm design. And so far we were, having challenges with the tilted playing field in the geospace, and we were hoping that cyberspace is going to level the playing field and everyone will get the same opportunity and accountability and the equality and transparency and fairness. But it seems that because of this, the way the algorithms are being developed and the bias is, getting embedded in that this is also becoming tilted. So, like you say, that we have to use the laws of discrimination we don't have the laws on algorithms. It will take maybe probably a decade before we come up with an effective regulatory system or effective legal and judicial system for the machine learning and robots and algorithms and all of this, drones and everything. But at this point we don't have that infrastructure. So the question is, like you suggested, we should use the laws of discrimination, but do we even have effective rules of regulations that can be effectively translated into this algorithm accountability? Because how do we measure performance of the algorithms? Do we have effective benchmarks? There are a lot of things we can do in geospace in the discrimination because it's visible and we can record that. But to measure the performance or to record these kind of challenges in the supervised algorithms, it's very difficult. So how do we go forward on that?
Well, some people have done some of these things already by, these well-known exploits where, people that are more or less from the white hat hacking community that try to find vulnerabilities in software. This is just another vulnerability. Bias is just another vulnerability. So, that's why you have these people, researchers and universities and so forth, that create rubber masks and things like that, or take pictures that exploit the vulnerability and point it out. And it's that sort of activity that needs to continue to basically punch holes in this stuff and to make it so that people understand what they're dealing with. Because as I said, it won't ever go away. But the only way is to manage it. It's like you can't get rid of criminals in society. It's just they're always going to be there. And you just try to minimize the impact through different types of things that society does. And so these white hat people that are involved in trying to find these exploits of these machine learning systems need to continue doing that, because I guarantee you that the nefarious hacker community is already licking their lips, so to speak, with respect to exploiting these machine learning systems as they form their attacks. And people start to use supervised learning for, data protection and that sort of thing, or preventing data from being corrupted, what have you. It's going to be possible for these people to bypass these things and get things into these systems. Like, look at the blockchain with Bitcoin, right? How many people? I mean, hundreds of millions of dollars have been lost as a result of hackers injecting stuff into the blockchain. That's one of the big problems with blockchain, is that if you get something bad in there, it spreads all over every place, and you got to shut down the whole network in order to be able to deal with it. So the point being is that it's just a matter of society having to use human beings to manage the technology, and realizing, that everybody needs to realize everybody, because it affects everybody. So even if you're not a technical person, you need to know that that supervised machine learning can be biased against you or your family or someone else, and to question the results. Don't just accept them blindly because the AI said so. All right, that's the worst thing that people can do, and no company that has any ethical standing would ever say something like that. I mean, if they did, I would be highly question them, or any government that would say something like that. So you really have to have human intervention and use existing laws, because there are no machine learning laws at this point to question the results and challenge them. And just don't. If somebody says to you, your diagnosis is this because the machine said this, okay, that's a red flag. Anybody ever said that to me, I'd say, I don't want to hear that. I want a second opinion by a human being that basically is not going to, that I can trust. You can't trust any algorithm. Okay? You can't trust an algorithm.
Sure, and I think I hear you on that. In UK, they have a regulation that, if a machine makes a decision, then you have a right to challenge that, and you have a right to have a human, look at all the data points and appeal to that. So yes, like you said, we do need humans involved, and any organization has a right to build any intelligent machine the way they want to. They supervised learning, unsupervised learning with whatever bias they want to embed into that. They have a right to do that because it's a private organization. But when it comes to the application for systems, when their algorithm is expected to be used for a public system or at any level, I mean, local, national, global, and maybe for government agencies or for education institutions or corporations trying to hire, people, or courts or prisons, then we need an objective as well as established best practices as to whose algorithm can be used for equality, fairness, and objectivity. Right now, it doesn't seem like there is any committee or any organization looking into that whose algorithms that are being developed are fair and objective, that we can use it in prisons or we can use it for government pension systems or healthcare systems. We don't have any such organization. So do we, at least from my understanding, we don't have any organization, but do we have any organization that test different version of algorithms and rates them for public use?
It's really not the algorithm's issue. The algorithm is the flaw, but the problem is in the result. So
yes,
what you end up with is basically a bunch of data that's processed using the neural net supervised learning algorithms, which are effectively little feed forward networks generally, where you have inputs that connect to other outputs, which connect to other outputs, and so forth. And this is what you're dealing with, is basically, a little, if you think about it, little wires that have numerical weights on them that create a weighted average of whatever goes in, and then there's an accumulator, which is the neuron. Very simple, nothing like a real neuron, and so it's extremely simple technology. It's the system that results that needs to be tested, and the only way you can do that is by applying it to different problems, trying to find vulnerabilities, because you can bet that the people that implement these systems, they test them, but that, at least at the big companies, but they develop a group consensus, and so they can't know to test it in ways that doesn't get the product out the door, so to speak, without ridiculous delays. So again, remember I told you that you can only train these things to 70%. You can't if you go between above 70%, but not to 100% convergence, because not only is that not possible, but that results in very narrow selection in the pattern recognition. You need to have, so there's vagueness built into the results. So the only way to deal with it is to have a human intervention, either by somebody else testing the stuff independently and showing the flaws, and people being generally aware, number two, that there's issues with this stuff, and number three, that you have the right to challenge the results. Those are the only three ways to deal with it.
Yeah, sure. Sure, that's a fair point. But I think from what I'm hearing is that probably we need to partner these intelligence systems or algorithms that are being developed with people who can mentor them over time, and to look into, just like a mother would tell a child that, look, this is right and this is wrong, you should not do this, and this is how, you can be an ethically, accountable human being when you grow up. So the algorithms are also, probably very infant stage, and we need to develop these mentors who can work with these algorithms, work with these intelligence systems that are being developed, and train them or mentor them to do the right thing and to get the bias out of the system, to audit them, and to make sure that we develop these accountable systems that are, fair and equal. And it's important to understand that unlike the systems in geospace, there are no established methods to test the digital systems for safety, fairness, or effectiveness in cyberspace. So we also need to develop these effective tools to
Yes.
test algorithms, right?
Now you can't get the bias out. I'll tell you something else that happened. Many years ago, when I was working at GT Government Systems, I spoke to a pilot, and they had this big program to integrate into the F-15, which at that point in time was a very new air superiority fighter plane. And they wanted to integrate voice recognition into the cockpit so that the pilot could issue verbal commands. They didn't use supervised learning, but they used, the types of voice recognition technology that is commonplace today. The interesting thing is it didn't work. They threw it out. The program failed. And the reason was because when the pilot is taking G-force, in other words, as you're diving or something like that, and you're taking G-forces during a maneuver where this high G-forces, your voice changes, okay? And the voice recognition system would say, I don't know who you are anymore, in the middle of a crisis. You follow what I'm saying? So the bias is always in these kinds of systems that are deployed based upon recognizing some, canonical representation of something. If you don't have continuous, unsupervised reinforcement learning, you cannot have, unbiased systems. It's just not possible. And the biggest problem is, there's bias in other AI systems too. But those systems, like things like Watson, there's bias in Watson. That's why it didn't do well in healthcare. When it first, they did great in Jeopardy, but, learning from Wikipedia and diagnosing people is a completely different thing, okay? It failed miserably in the first deployments of Watson, IBM Watson in the healthcare industry. So the problem is also made more complex by the people that are working on these systems not knowing what they're doing. Let me explain what I mean by that. They may know very well how the neural network works and so forth and the limitations of it, but they might not know the deployment environment very well. And that's what happened, for example, with IBM Watson, which is not just, it has a lot. IBM Watson is a giant knowledge-based system. And when they trained it to recognize everything in Jeopardy, it did really good in Wikipedia, and therefore it did well in Jeopardy. But the same kinds of information is not available in healthcare. Generally, and from being in life sciences, zillions of papers are published every year. and only a few of those are any good, okay, in life sciences. So what the researchers thought was, gee, if we just look at all the research papers, we'll be great. Wrong, okay? So because of their lack of understanding of the domain that they were in, they were basically training Watson to look at all this junk that doesn't make any difference. You follow? So that's another part of the problem, is that the AI researcher may not be knowledgeable in the deployment space. They may be knowledgeable in saying, okay, give me the training sets, and I'll, they know how to say things like this. I need examples that look like this. Okay, I need some extrema, because that's how you train these systems. You have extrema of examples, okay, of things. And then they can massage them, and then they can encode them. They know how to do all these things if they are, they know what they're doing. I'm not talking about people who apply them like black boxes. Somebody that knows how to apply the algorithms, really engineer them, like some, really good data scientists and things like that. But they're not going to understand necessarily the actual domain. That's why when I, was in life sciences and I was doing quantum chemistry stuff, I designed real molecules, okay? I designed real therapeutic compounds that actually worked. Because, and I have a saying, you don't know if it's going to work until it doesn't, all right? So you have to, get in there and apply the thing, and you can't just rely upon somebody else to give you input and you come out with an output, because they're not going to necessarily know, other than the thing doesn't work, what happened. So it's this is something that I see lacking generally, is that people over-specialize, and they basically don't have the ability to take into consideration, points of view. During my work in doing drug discovery, early stage drug discovery, I was always amazed at these computational chemists, at some of the crap that they would come out with, literally. These molecular structures that nobody could build, okay? You know what I'm talking about from being in the life sciences, these computational chemists would come out with these things that would be, very elegant molecular structures, using their technology. However, nobody, you might be able to build one. You might be able to find a synthetic chemist to build one, okay? But you could never get it into production. It would be impossible, too costly. So they don't take into consideration these things. Or clinical trials, they basically don't understand, they never understood, I saw, what really happens in clinical trials, what causes drugs to fail. So if you don't understand the system, what's taking place from soup to nuts, okay, then you're not going to be able to understand what the issues are, and be able to say, okay, well, this is where my system might break down. And that's why you're having these things take place at Apple and other places where the system breaks, because the guys, people that are doing this stuff, don't have that background, and so they're not looking for it. You follow what I'm saying?
Yes, of course, I hear you on that. So, we do need that kind of diverse committee, or, diverse group of people who work together, because, we don't want a single-minded thinking. But also coming back to the point about the algorithms that are already very deeply embedded into the human society, over human systems, and they are already biased. So what are your recommendations? How do we go forward? And which algorithms at this point, if we talk about the United States, which algorithms needs outside review that concerns you at this point?
It's a pickle. That's what it is, okay? Really, because you can't know when you're being evaluated by, a neural network, the supervised learning system. You just don't know, because these things are like embedded. They're embedded inside. And it's so easy to deploy this stuff now, and the processing speed. You can put these things on cell phones, okay, or even smaller. You can put them on an iWatch. It doesn't take much. In the old days, you couldn't. You had to have fairly powerful machines, but that power is now available in these little bitty things. So you really don't know when it's going to hit you. You just have to be aware and be educated. That's about the problem. It's really just a pickle. You just can't get away from it. And that's why I moved away from this stuff years ago. And it's really fundamental to how these supervised learning algorithms work. They just are biased. It's just the way you cannot get away from that. It has nothing to do with the training sets. As I said earlier, if a machine was designing these training sets, wouldn't have anything to do. They would still be biased. So it's a matter that it's just something that's, you have to take the good with the bad. There's some good things that can take place from this stuff. It's not like it's going to destroy the world or be used to control the red button on the president's desk to set loose nuclear weapons or something like that, because people know better, okay, for that sort of thing. But the point being is that it's going to be there, that there's going to be these insidious things taking place. Hopefully the benefits associated with what comes out will be worth the downside risk.
But is that the approach that we should be taking, that we should just accept that yes, this bias would be there, there's nothing we can do about it?
If you can,
is that the approach to go forward with?
As long as the supervised learning algorithms are used, you can't get away from it. The only way, technically, if you want to basically get away from it, you got to go to unsupervised reinforcement learning. Period. End of story. That's it. Okay? You just got to drop supervised learning like I did. I stopped using that stuff in 93. Okay? 1993. It was just, I knew it was a dead end. So I stopped using it. I went away from it altogether. You have to use reinforcement learning, unsupervised reinforcement learning. The problem is most people don't know how to use that stuff. And it took me a long time, decades, to get it so that it would actually be used. So, because I came from a perspective of supervised learning systems. And so when I started to use reinforcement learning systems, I was kind of using it that way. You follow what I'm saying? In other words, it's like you have a new tool, but you're using the new tool like you used the old tool. And that's no good. Okay? So you have to think from a completely different perspective, which means how you engineer the reinforcement learning has to be very different than.
Sure, I agree with you that we do need a new approach. But the challenge with these systems, once we develop, it's very hard to overturn, because there is so much investment that has gone into that, and there are so many high-profile players that are involved in those systems. So once the system becomes established and it has becoming widely accepted and used, then it's very difficult to overturn that and say, insert another new technology or new process that is more effective, that is not biased, and that gives us the accountability and equality and fairness that we are looking for. Because these are entirely different issues we are talking about. It's not just technology or processes, it's about the investment and investors and the system that has already got embedded. So there are very complex challenges we are facing here.
Yeah, you've got that nailed. These are very complex challenges, and all you can hope for literally is, as long as these supervised learning systems are in place, that people become aware that they should challenge the results if they don't feel they're correct. They should do so. They should use existing laws that are in existence to file complaints and so forth. Just because it doesn't make a difference if it's a human, discriminating or an algorithm. Or more specifically, the training, how this thing's deployed. People shouldn't be deploying these things in mission critical applications where there could be, possibilities for this kind of algorithmic abuse, if you would. But you can't stop it because there's no regulations. People do what they're going to do. The thing is, education and knowledge about these systems, not just believing that, that they're the end all. And they're going to be there, and even when reinforcement learning starts to overturn all this stuff, and I think that was, I did it, so other people will do it too. Rich Sutton's been working on this stuff since I've known him. He's my age. He's 63 years old, and I knew him, when he was first doing this stuff when he came out of Stanford with his PhD in computer science, he's been working on reinforcement learning forever. He hasn't been swayed. Okay, and if you talk to him, he will tell you. Well, he's not as outspoken as I am. He's a little bit more politically correct in that sense. But in the context that he sees the issues with this. And privately, when I was using this stuff way back when, and I had an office right near his at GT Laboratories. He was saying that stuff is crap. Don't use it. And he even wrote a paper saying that it wouldn't work. Okay, but he was incorrect because you could get it to work by not having 100% convergence. But the problem is that if it's not 100% convergence, okay, for number one, 100% convergence doesn't work, okay? Number two, if it's not 100% convergent, it does work, but it's going to be biased. You follow what I'm saying? All right? So you're stuck with how the stuff works. You cannot get away from it, all right? If you could get 100% convergence, that means that every single thing that you did worked, and it has perfect generalization. That doesn't happen, okay? That never happens, all right? So they'd never shoot for it. It doesn't. It results in too narrow selection. You know, if you try to go for that kind of training results, because what happens is, like in backpropagation, you get you have a data set, and then it propagates through the network using very simple calculations, and then you get a numerical result that comes out, and you compare that to the desired result. And so you can basically say you made a mistake, and have the for example, backpropagation, propagate the error back through the network, making small changes on the links, because that's where it takes place. The nodes don't have anything to do with this. It's all on the links, and that's where the weightings are. And then you try it again. So you can keep making that error correction over and over and over again to like 20 decimal places. But if you do that, what's going to happen is that you're going to have very narrow selection. It's going to be very brittle, and that's why you can't do it. You have to have the system be somewhat fuzzy for it to work and generalize well. But at the same time, that results in bias. So you're stuck with it.
Yes, we are stuck with it at least for now, until we figure out, how to correct it, and how this is just like, human learning versus machine learning. And humans, we learn in a very different way. The way our brain works is very different. The machines, they learn in it in a very different way. So hopefully that this machine, the supervised learning and the supervised machine learning and the data sets that they're using, that as and it's very complex, and we don't know what variables get inserted. We don't know how the mistakes happen. We don't know how, we do know few areas where how the bias gets embedded, but there are a lot more complex things that are happening when we are developing these algorithms and systems. So hopefully that in the coming years, someone who is working to overcome all these biases will be able to figure out how to audit these algorithms and how to correct them, and hopefully come up with better ways to make it a fair and equal system. But until then, let's talk about the approach that you have developed, which doesn't involve the supervised learning, and which hopefully does not create the biased algorithms that are the talk of this discussion, and we are trying to prevent that bias getting into these algorithms. So let's talk about the QAI and how it addresses the complex challenges of the algorithm bias.
So QAI is a unsupervised reinforcement learning system that uses a couple of different technologies. It uses this, first and foremost, it uses something I call quantum signaling. Quantum signaling is a kind of wave propagation. So if you send a message, if a neuron inside QAI sends a message, there are no connections. So neurons of QAI don't have connections, okay? In neural networks that exist today, supervised learning systems, the connections are the locus of activity, not the neurons, okay? And real brains don't work like that. There's no error signal being propagated back through your brain, basically saying adjust all these weights and the links. Okay, so QAI is connectionless. Current neural networks use connections. That's called the paradigm. It's called the connectionist paradigm. It's been around for decades. QAI is a connectionless paradigm. The neurons communicate through message diffusion, where the messages diffuse. Like if you were to throw a pebble into a pond, and you'd have this wave spread. That's how neurons and QAI communicate. You have a message diffusion, but it's quantum message diffusion because it obeys the laws of quantum mechanics. Meaning that if you threw a pebble into a pond, you'd have a wave propagate, and there are other rocks, for example. The wave would propagate against the rock, and there maybe be some reflections, but it would continue to propagate. And quantum mechanically, that doesn't take place. As soon as the wave hits something, like the rock in our example, the wave stops. It goes away, and it doesn't propagate any further, except under very special circumstances, which have to do with if there are two rocks in our example where the wave is propagating and hits them at the same time, they'll both receive the message. So using this quantum signaling results in a kind of self-organization that I was able to discover this by using it to model molecular systems in a new kind of quantum chemistry that I call energy mechanics, which doesn't use the conventional approach to molecular orbitals and so forth. And the technology I invented, using quantum signaling, what happens is that each particle radiates, as I described, using this quantum signaling, and the interactions, which are on the order of move towards something or being repelled from something, result in the structures that define chemical bonds and so forth. Okay, so the first thing was this quantum signaling that I implemented. Now, the other thing was the actual reinforcement learning. Most reinforcement learning systems require lots of data and ridiculous amounts of time to train. I saw that. I knew this was a problem. For forever, I knew this. So what I did was I came up with an approach that doesn't use the direct signal as the reinforcement learning basis for decisions. Instead, what I did was the following. Let's say you have a signal come in, and let's say it's a signal that varies between 0 and 1. Let's say it's based upon, and QAI looks at information entropy, and it fits well with the quantum signaling because it's looking at the information entropy, that is to say the randomness associated with the signals that are flying around inside the cognitive reactor. And so what it does is it looks at that signal, and then what it does is it solves a very simple task. What it does is each neuron moves a location pointer on a little track. It's inside the neuron to reflect the input to the neuron. And when it does that, there's a velocity and an acceleration associated with that movement. It's guaranteed to converge. So the reinforcement learning in QAI is guaranteed to converge mathematically. Okay, so that's very different than supervised learning systems, which have no mathematical proof of convergence. This one does. Okay, and what it's converging upon is moving this locator. The result of this locator moving is velocity and acceleration and other things like the Bellman error, which are well known in machine learning, which are a way to measure the accuracy of a machine learning system. And in this case, it's measuring either the erratic nature or the non-erratic nature of the movement of this locator on the track. Okay. Which is very much like the pole balancing problem, but applied in a very novel way. Pole balancing is a well-known reinforcement learning application. I won't get into that. It's lots of information on the internet, but effectively what you're doing is you're learning to balance a pole on a track where something's moving back and forth and the forces of gravity are trying to pull the pole down. It's on a hinge. Anyway, it's been around forever. But the point being is here, I take these metrics, which are associated with the velocity, acceleration, and error that come out of the neuron very rapidly, and I use that to generate signals. So, for example, if you think about in the human brain, if you recognize something in the human brain, okay, that effect, there's a chemical stimulation that takes place where chemicals are released in different quantities, cortisol, what have you, okay, in order to make the rest of the system behave in a more attuned way. Well, that's exactly how it works inside QAI. The reinforcement learning does upon recognizing, for example, that there's randomness in the signaling that's taking place, or the lack thereof, okay? what it does is it broadcasts a signal, no different in terms of its function than releasing large quantities, for example, of endorphins or something like that to stimulate different parts of the brain. These signals that pump out, okay, from QAI, also from the neurons rather, the reinforcement learning neurons, have the effect of stimulating other neurons to an exaggerated state because something is recognized something has taken place. If the input changes, okay, that signal is clamped. It damps down, and the system returns to whatever normal basis it was. The overall effect on the neurons in the system is that because there's no connections and they're interacting just like cell phones, okay, where cell phones are like interacting, although you're on a telephone call with only one person, the cell phone actually sees all kinds of signals, okay? The neurons here are doing the same thing. They're looking at all these signals, and so in the same way as a chemical bond has a certain energy level associated with that communication, okay? A hydrogen bond is unlike a chemical bond because the energy level is very low, okay? But nonetheless, it's based upon the same quantum electrodynamic phenomenon of force carrier exchange. It's just a less energy associated with that exchange. All right. So van der Waals interactions, things like that, are as a result of the same quantum electrodynamic phenomenon, just less of it. All right. Chemical bonds are very difficult to break because of the energies involved. All right. That just means that there's lots of photons going back and forth. All right. Less so for a hydrogen bond, but just like in water, where hydrogen bonding can have a very strong effect because it's distributed across lots and lots of water molecules, in the same sense inside QAI, the neurons have all these different interactions taking place, and that's the basis for them forming deep networks, okay? Deep learning networks in QAI are the result of these weak interactions that are constantly taking place. So these weak interactions can be influenced by more signals being pumped out. Does that make sense?
Yes.
All right, so that's how I get away from the unbiased nature of it, because it's completely independent of any kind of data that's coming in. It's purely looking at information entropy. In other words, things which are less random, and it instantly changes over time. And it will also, so a deep network that might form in QAI will suddenly change, if some new information comes in. It's never biased to any particular position. And so that's one of the reasons why, in terms of the way it works with Bitcoin, is that the actual hash codes that are used to identify the indexes for the blockchains. So each block in the blockchain it's a tree structure, and that tree structure, the links between the nodes are indexes. Those indexes are the hash codes. That's what's being calculated. Okay. What happens with QAI is the Bitcoin core feeds QAI all of the hash codes. They flow into QAI as signals. And so the neurons in QAI are able to recognize them and analyze them and look for similarities. Okay? So in the same, and these similarities, okay, which could change over time and will, so there's no bias. It changes over time because you have different data going into the blockchain, which results in different hash codes, because each hash code is unique to a particular block. All right. If a hash code is close to another hash code, it just means that those two blocks are close together in terms of their similarity. So, like a molecular fingerprint, if you have two fingerprints that are the same, then you're dealing with the same molecule. All right. So in the same sense here, the hash codes are like fingerprints for each one of the blocks. And so current mining operations don't take this into consideration. They just generate the hash codes using brute force data independent methods. What QAI is doing is by looking at the hash codes in the public Bitcoin the public blockchain database. It's able to say, okay, we don't have to worry about these kinds of hash codes. The probability that we're going to have to generate something outside of this boundary is low. So we're not going to do that. So it directs the mining technology, okay, to not focus on those types of hash codes. Does that make sense?
Yes, absolutely. I mean, this is very promising. So, what stage is your development of this technology? Are you, is it commercial? Are you developing any applications based on this?
Well, it's actually we're testing it right now, and it's running. In fact, right now it's running, and it's another aspect of QAI is that it's based upon it's a 5-dimensional model, mathematical model. Okay, now it's a very complicated system. Now, during the Cold War, I was working on some complex problems in particle physics, and this is back in the late '80s. And I started to take what's called a digital physics approach to the problems, in the hopes that I might be able to address the interaction. So what I was working on was quark interaction. So if you think about, the physics standard model, chemistry is based upon quantum electrodynamics. The exchange particles there, everything happens linearly. Inside the nucleus of the atom, we have quarks that make up protons and neutrons. The interactions between quarks are nonlinear, so the calculations are much more difficult to perform, and that's what I was focusing on, were essentially nuclear forces. And so I realized that I didn't want to use perturbation. The existing methods weren't perturbation theory and so forth weren't working for me, and so I came up with this digital physics approach, which was a string theory. I took something called Kaluza-Klein theory, which is the granddaddy of all string theories, and I adapted it to digital physics. And I quickly realized that what I'd come up with could be applied to any problem. And so that is also integrated into QAI. Now, the thing that's neat about this is that the neurons in QAI, so this is a 5-dimensional space. You have 4 dimensions, which are 3 dimensions plus time. It's continuous space. So it's in mathematics we call it a differentiable manifold, meaning that you can perform calculus on it. Okay, so you figure out accelerations, velocities, and so forth as the space deforms. So if you think about, for example, molecules, which I know you're familiar with, if you think about a chemical bond, all right, a chemical bond is a higher energy area. So to represent it using this kind of digital physics formulation, what you would look like, you'd see like a topology where there'd be an energy well, which is deeper than the surrounding areas because that's where the chemical bond is taking place. Does that make sense?
Yes.
We're a hydrogen bond, which is much weaker, which have a much weaker well, a much weaker energy well. So because QAI neurons work this way, they actually exchange information using this type of quantum signaling. You have the same types of topologies. But in this case, the neurons exist in one of the dimensions, in the 5th dimension, which is what's called flux compactified, meaning that when the neuron expresses something, sends out a signal, it basically is projecting in the other 4 dimensions because where it is and how it is interacting. Now, because of that, it has the ability to interact non-locally. So if you think of a piece of cardboard, and let's say the neurons are projecting to one corner of the cardboard, so say it's a rectangle, and they want to interact with another portion of the cardboard. That happens instantaneously. It's not necessary for them to traverse the signal space in the 4 dimensions because they're existing outside that. Does that make sense? Because they're okay. So the value of this is that QAI can avoid computational local minima by folding that computational space. So if you can imagine the corners of the cardboard that I just talked about, if the cardboard at each corner represents the beginning of the problem, and at the other corner the end of the solution, and in between all kinds of possible solutions but incorrect solutions, local minima. What QAI has the ability to do mathematically, the way it works, is it literally folds the space together because the neurons can just look at that other corner. So it bypasses all those false solutions and jumps to the solution, which is the right solution, instantaneously. It's very fast. So it's a very different system and blockchain is an excellent application for a couple of reasons. One is because it's solvable. I know the space because I used to do a lot of work in cryptanalysis, for the National Security Agency. I understand the SHA 256 because I helped with it to design its predecessors, using this data-dependent. I mean, think about the Enigma machine of World War II. Okay, Germans had this machine to encrypt their communications. Bletchley Park in the United Kingdom was able to break that machine. How did they do that? The way that they did it was by data-dependent decryption. They were able to find out that every message that the German High Command would send would always have a certain phrase in it. And as a result of knowing that, even though they didn't know what the encrypted result was, they were able to use their own computer to basically converge on that particular phrase in the encrypted data. And then from there, they were able to expand out and break the rest of the code. And that's why after they broke that, they did not use the result of the breaking of the German codes on all the different problems during the war. They were very careful so as to not provide solutions to field commanders. In other words, they would say, go over here because there's going to be a battleship or something, okay? Sometimes they wouldn't do that because doing so would alert the Germans to the fact that they'd broken the code. And as soon as they would do that, all the Germans would have to do was change how they would be sending the messages and some of these things that they always stuck in there.
Yes.
Okay? And the entire form, they would have to start from scratch again. So in the same sense, so data-dependent decryption, breaking of codes, is the way to go. Otherwise, you're dealing with an exponential problem, all right? Right now, blockchain uses data-independent hash code techniques, which is very elegant mathematically, easy to implement in hardware, but it's ridiculously high computational cost. That's why you have all these mining technologies out there using ASICs and so forth and so on, application-specific integrated circuits, and so forth. With QAI, analyzing the entire blockchain, because it's a real-time system, it's highly parallel, the GPUs uses FPGAs, it's very fast, analyzes the blockchain, narrows down the search horizon associated with identifying the next signature.
Sure. That seems very promising, and the data-dependent decryption, I think, probably is the way to go, and hopefully the real-time data. We should not look at the data of the past because that already has so much biases. So we should try to go for real-time data, and if we are able to develop systems based on that decryption technology, real-time data decryption technology, I think we will be able to eliminate a lot of biases that are already there in in geospace and emerging in cyberspace. So let's hope that we are able to do that. So what would you like to tell our global viewers and listeners, especially the young minds who are trying to make a difference through technology?
I would say, in the context of our discussion today with respect to bias and supervised learning, is to not accept, the results if they don't seem right to you. You need to challenge that, because otherwise, you could be the subject of bias, and it could affect your life. So you need to really challenge it.
Yes, very true, very true. You have to be educated, you have to be informed, you have to be intelligent, you need to understand where the complex challenges are emerging, and you have to speak up. You should not accept any wrong. You should try to right any wrong. So there is a lot that needs to be done in identifying, isolating, and eliminating the biases that cause artificial intelligence to take decisions that either endanger human life or discriminate, irrespective of whether it's cyberspace or geospace, is one of the biggest challenges facing machine learning developers today. And thank you so much, Lars, for participating in Risk Roundup today. We appreciate your thoughtful insight on biased algorithms and for calling attention to it, and also for all your efforts to correcting them as best as we can. So our global viewers and listeners will benefit tremendously from the information you provided on biased algorithms, on your initiatives, and the risk it brings to the society. So even if a single individual or entity can come up with an idea to help remove the bias and help bring equality and fairness in cyberspace, geospace, and space, this Risk Roundup dialogue has been of service, and we thank you for that.
Thank you for having me.
Wonderful, Lars. So we at Risk Group call attention to risk impacting humanity at all levels, and we speak out about our biases that bring inequality, emphasize them, raising awareness of their existence, and educating individuals and entities across NGIA, that means nations, its government, industries, organizations, and academia, and making every effort to correct them as best as we can. By identifying the problem and raising awareness for it, we take the first step in beginning to address it. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. It is not possible to conceive any one of the three without the existence of the other two. All three concepts fit into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if you build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the risk roundups, to watch the risk roundup videos or hear the risk roundup podcast, please go to riskgroupllc.com, and do not forget to subscribe and share. Until next time, I'm Jayashree, host of Risk Roundup, signing off. See you next time. Thank you.